Welcome to All This Math. This is Professor Parker, and today we're going to do some synthetic division. Now, synthetic division is an alternative to the polynomial long division, which is a method of dividing a polynomial expression by another polynomial expression. All right? But synthetic division is a little shorter, and it's more straightforward, and it doesn't require as much mathematics. So it's helpful. It'll be helpful to you when you get into some of the higher algebra 2 topics and the pre-calculus topics when we're dealing with graphing cubic equations and the curves of cubic equations. But it's a good building block skill to have. All right. So synthetic division. And if you have any familiarity with polynomial long division, you'll see why this is considered to be synthetic division, because it's still division, but you're not actually doing all the steps of polynomial long division. All right, now let's take a look at what we have here. We have this polynomial expression, 3x cubed plus 4x squared minus 2x minus 1. This is called our dividend, right? The first expression is the dividend, followed by the divisor. This x plus 4 is our divisor. Now, we can't use synthetic division in every situation. In this situation, we can use synthetic division because of what our divisor looks like, all right? Our divisor is to the first power, meaning the degree 1, meaning the biggest exponent in the divisor is a 1. So we have x to the first power, right? If we had x to the second power or x to the third power, we wouldn't be able to use synthetic division. Also, our coefficient of the x term is a 1. We know it's a 1 because there's no number written adjacent to it, right? So there's an invisible 1 in front of the x. So that also is another reason that we can use synthetic division, all right? So those are the two things you need to keep in mind when considering whether you can even use synthetic division. Now, how do you actually do it though? This is how you do it. You take this constant term that's in the divisor, in this case it's positive 4, and you're going to take the opposite of that. You always take the opposite of that, all right? And then you write a negative 4, and then you write a big L, like this, right? Negative 4 outside, and then a big L, all right? Now, inside the big L, you're going to put the coefficients of these these three terms, and then this constant. They're going to have their own columns. So I'm going to take the coefficient of x cubed, which is 3, and I'm going to write that right here. Then I'm going to take the coefficient of x squared, which is 4, and I'm going to write that right here. Then I'll take the coefficient of x, which is negative 2, and I'll write that right there. And then this constant is negative 1. All right? Now, in this particular dividend, everything is in descending order, right? We look at our variables. We have x to the third, x to the second, x to the first, and this could be considered 1x to the 0 power, right? If you're ever missing any of the terms or any of the exponents, you would just simply use a 0. Now, this example doesn't have that, but what I mean is, if this only said 3x to the third minus 2x minus 1, you couldn't write 3, negative 2, negative 1. You would have to use a placeholder to represent that x squared term that was not included. So you would put a 0 there if this didn't have an x squared term. So you would treat it like it did, but just think of that x squared term as 0x squared, and you will put a 0. All right. I'll probably do another video where there's an example that's exactly like that in order to better explain what I'm actually talking about. But now for this example, we have 3, 4, negative 2, and negative 1. This is how we do synthetic division. We add vertically, and we multiply diagonally. We add vertically, and we multiply diagonally. All right? So this starts out like this. I take this 3, and I add it to 0 because there's nothing there. So 3 plus 0 is 3. I write the sum underneath of the line. So I just added vertically. And then I'm going to multiply diagonally. So I multiply this negative 4 by this positive 3. Negative 4 times positive 3 gives me a product of negative 12. I take the negative 12, I put it in the next column underneath of this 4, right? So now I got 4. Now again, I just multiply diagonally. So now I repeat the pattern. I'm going to add vertically. 4 plus negative 12, which is the same thing as saying 4 minus 12, which is going to be negative 8. All right? Now I'm going to multiply diagonally again. Negative 4 times negative 8 gives me positive 32. I put that in the next column, like that. Now I'm going to add vertically again. Negative 2 plus 32 gives me 30. All right, that gives me 30. Now I'm going to multiply diagonally again. Negative 4 times positive 30 is negative 120. So negative 120. And now I add vertically. Negative 1 plus negative 120 is negative 121. Right? Now, we've done all our addition. We've done all our multiplication. Now it's time to write what the quotient would be. Because remember, this is the dividend. This is the divisor. And what it will be equal to is the quotient. The quotient is the term for the answer when we do a division problem. All right? Now, this last number right here, sometimes it'll be a 0, sometimes it won't. In this particular example, it's not a 0. This last number right here is our remainder. So you can just write capital R to represent remainder and negative 121. I'm going to show you the fancy way to write the answer, though. But for now, we're just going to say R is negative 121, meaning the remainder is negative 121. Then you kind of work backwards to write your expression. Now, this expression or this quotient should be 1 degree less than the original dividend. 1 degree less than the original dividend. The dividend had a degree of 3. 3 is the biggest exponent in the dividend. So our quotient should have a degree of 2 because 3 minus 1 is 2. All right. Now, this positive 30 is going to be the constant in the expression. So that's going to be at the end. And it's positive, right? This negative 8 is the coefficient of the x term, the x to the first term. So then you'll have minus 8x. This 3 is going to be the coefficient of the x squared term. So we have 3x squared. And that's how you take these 3 numbers and use them to create the expression that represents part of the quotient in this problem. I say part of the quotient because this has a remainder. So instead of me writing, I could just write, it depends on what your teacher's, predilection is, right? If your teacher is satisfied and content with you just saying 3x squared minus 8x plus 30, remainder negative 121, then by all means, just rock out and just leave it like that. But the more sophisticated way to write the answer would be similar to the way that we create mixed numbers or mixed numerals in pre-algebra, right? You would take this quotient, right? You would say 3x squared minus 8x plus 30, and then you take the remainder and divide it by the dividend, or you represent that as a fraction. So this is a negative 121. So then I would write minus 121 divided by the divisor, which is x plus 4. So this would be like the more sophisticated way to write the answer when there's a remainder involved. There won't always be a remainder involved. And the way that you know that there's a remainder involved is the fact that this number right here is not a 0. The number that's in this space is always going to be your remainder. All right. So that's just a little bit of synthetic division. I just wanted to get into that today. I was going over that with one of my students during the tutoring session last night, and I just wanted to put this out there, create this video. All right. So please like the video, like the page, subscribe to the page. Tell some people about it as usual. And as always, do remember that there's all this math all around you. Peace.